All right, so here we are. My name is Dustin Hartnett here with Lab 5 for ENME351. We're going to start us off with this MATLAB simulation part. So started us off, I copied it all into MATLAB, changed anything I needed to with these initialization values with the RC, Vn, and the time constant. Here we're setting up our length of the experiment, which is 0 to 10, basically, with increments of 0.1. And then for the simulation aspect, we are going to take, for each of the resistances, 10 kilo ohms and 100 kilo ohms, we are going to calculate the voltage of the capacitor given voltage in, which is always 5 volts, which is equal to 5 volts minus 5 volts times the exponential of the negative t, which is the time at that specific spot, over the time constant, which is equal to R times C. Now, we will plot that, so the plotting is all of this, and we'll see what that does here. We have our blue is the 10 kilo ohm, orange, red is this 100 kilo ohm, and everything else is the step functions from 0 to 5 volts, the perfect case situation. So now to step over to this Arduino code. Here we have the setup, pin modes, digital writes, initializing the constants, R and C, putting the integers of V and VC, float tau equals R times C is the time constant. Then for 0 to 500, which is if we're sampling the voltages at 1/50th of the time constant, the 10 times time constant duration for which these ons, highs and lows should be held is equal to 500 times 1/50th of the time constant. So we'll do 500 iterations of this loop, incrementing by 1/50th of tau times 1000 to make it in seconds. And we'll be reading in Vn and Vc using analog read, and then printing them with a tab in between to the processing. And then we're going to switch it on to low and do the same exact thing and watch it discharge. And then that swings us over to the processing here, which we see we'll basically take it all in, set up a nice array of data, or 2 arrays of data, add columns, sets up your background and your screen and your oscilloscope, and then we'll pump in data pieces one at a time in a continuous string as this circuit here is running with our resistor and capacitor, and we'll see what happens. We'll hit play. Oh, my port is busy. Disconnect. Hit play, and it should give us in a second an oscilloscope. Yep, there we go. You see it charging up to reach that. The green is the V capacitance, and the red is the V in. So as the V in changes from 0 to 5, and from 5 to 0, the V capacitor gradually goes up and goes down as it charges and discharges. All right, and on to the MATLAB simulation. For our final part, taking in this data from processing that we just used or calculated, we are coming in here to our second aspect, setting up our R and C values and our time constant. And then right here, we are loading in the data that you can see over here from our processing. Then we have for our 10 kilo ohm and 100 kilo ohm resistor. And then here it strips the data from each other and allows us to graph it against our time array and plots with a lot of X labels, Y labels, titles, and legends, and everything that is important for identifying your data. So we'll run that with this 10 kilo ohm, and we see that the red is the V capacitance. It charges up very quickly and discharges very quickly. This is all in the span of 2 seconds. Now, if we switch this to 100 kilo ohms to see what happens there. Oh, yep, okay. We will run it again. Oh, I'm sorry. I need to comment out this data and uncomment this for the right data setup. And here we go. This is only, the period is 10 seconds because the resistance is higher. The whole discharge is you know, a little dragged on. You see it comes up and reaches that 5 volts, and then we'll discharge again on this other side here. Awesome. Thank you very much.